Dear students, welcome to another lecture in Industrial Engineering and Quality Control. We were discussing about method study. In the method study, we have seen till now various recording techniques that are employed in the method study. You see, this is the list that earlier we have seen. So till now what we have seen are this outline process chart, flow process chart, all the three types, and two-handed process chart, then multiple activity chart, SIMO chart. All these things we have seen. Even in the diagrams indicating movements, we have seen flow diagram, string diagram, we have seen travel chart also we have seen. Now only these two are remaining. What are they? Cycle graph and chrono-cycle graph. Now let us discuss about the cycle graph first. So this cycle graph, we employ it for studying the movements of an operator's hands, the path of the movement of the operator's hands and fingers. It's a spelling mistake here. See, a person's hands, how they are moving. See, this graph, it traces the movements which are too fast for human eye. Why? When do we use a cycle graph? When no, our naked eye cannot detect the movements, because the thing is very fast. The movements are very fast. So then, because at that time we use cycle graph. You see, this is a photographic record on still film. Still film means not video. It is a still photograph sort of thing of the path of motions. Actually, these are all techniques which are used much before, and what we are studying when the photographic film and other things were used. Now digital things have come, but only that we are still studying the age-old photographic films. Okay, this textbook need to be updated. To make the cycle graph, a small electric bulb is attached to the finger of the operator while he is performing the operation. You see, he is working on the machine, or on a workstation he is working, and his actions may be very fast. Sometimes they'll be working very fast, and our naked eye we cannot see how many times the hand is moving and all. So for that, what we do is we tie a small electric bulb to the operator's finger. Okay, and then we'll take the photographs of that, and the path of the light bulb moves. As it moves through the space, you see, it will generate a curve like this, a continuous path like this. Okay, see, when the film is developed, the meaning of here, it means it is a still photograph and film is developed like that. You see, nowadays digital techniques have come, though they can be employed. Okay, but in the olden days they used to take it on the film, so that's what we are saying here. After the film is developed, the resulting picture, which is called the cycle graph, it shows a permanent record of the motion pattern employed in the form of a loop, okay, with a continuous line with the working area in the background. The working area will be in the background, and this person is this continuous path of this cycle graph is in the foreground. Okay, the path of light so photographed is called cycle graph, as shown in the figure. The cycle graph does not indicate the direction or speed of motion. See, this is one of the disadvantage. You see, whether the finger has moved from this side to that side or that side to this side, we don't know. And at what speed did it move? Where did it move? Very fast or slow? We don't know. See, the bulb that is attached, as it is, the light that is emitting from that bulb, which is attached to the finger of the worker, you see, that is being captured on the still photograph. Okay, and when you develop it, when you wash it, you get a path like this. So you will know that this is how the worker is moving his fingers. Okay, so here now when we are doing the cycle graph, the working area is kept relatively less illuminated, means a little darker, and it is relatively less illuminated, so that this continuous path can be clearly seen. Okay, and when you are using, you can use more than one camera to get more details of the graph. Okay, so a graph like this, to know the path, you see, this is called a cycle graph. Okay, you see, these are all part of method study. We are studying the methods. Okay, next let us see the chrono-cyclograph. Now, chrono-cyclograph, this is also introduced by Gilbreth. Gilbreth was that person who has proposed Darblig's. Okay, so this is similar to the cycle graph, but only that it is a modified version of it, because that was having disadvantages, because we didn't know which is the direction of motion and the speed. But two things we didn't know. Those are the disadvantages in that one. But now in this, we can overcome those disadvantages. Here, instead of one bulb, a series of bulbs are used. They are tied to the hands or the fingers of the operator. See, the bulb interrupts the light source 10 to 30 times per second. See, per second. You see, 10 to 30 times per second, it keeps flickering. Okay, so and thus instead of recording because it is flickering, it is not, whereas in cycle graph it is continuously glowing, whereas it is here, it is coming on and off, on and off. Okay, therefore what we are doing, instead of recording a continuous path, continuous lines, this chrono-cycle graph records pear-shaped spots. That means it will not be continuous, like a water droplets or something. You will have the photograph plate. Okay, on the photograph plate, the point, and I will show you how it looks. You see, this is how it looks. This is not a continuous path. Okay, it is you see, pointed ends are there. So that shows the pointed end shows the direction of movement, and the closer they are, the slow speed, the further they are, that means the speed is more there. Here they are close, here the speed is reduced, but here the gaps are little more, and so here it was faster. Okay, like that we can conclude from this. And suppose in one place there are more than many pear-shaped dots are there, then what can we conclude is that the person has stumbled there or something, or he took more time there, like that we can conclude. Okay, so that's what here. The wide spacing would represent fast movements and close spacing would represent slow movements. And if jumbling of dots at one point have taken place, means it shows the fumbling or hesitation of the operator's body. Okay, and more elongated spots with longer gaps between them mark higher speed, more speed. Okay, this chronocycle graph, it can be used to study the motion patterns and also to compute the velocity and acceleration retardation experienced by the body member at different locations. All this information you can get it. Okay, by knowing the rate at which the light source is interrupted, the speed of movement can be easily determined. You know at what frequency, at what rate the light is flickering. Okay, then thereby you will be able to calculate the speed and other things. Okay, by knowing the rate at which the light source is being interrupted, this is the same statement repeated. Okay, this is the chronocycle graph is. And the next, let us see the Let us see the advantages of cycle graph and chrono-cycle graph. See, these record all the movements which cannot be recorded by the naked eye. This is one advantage. That's why we are employing these things. And then they are used to develop most economical pattern of movements. It is economical. That means it is not so costly. That's what this third statement also says. They are not very costly for the information they provide. See, it doesn't mean that they are very cheap, but the information that they are providing, for that it is worth paying that money. Okay, then they can trace very fast motions also. Sometimes in some of the big cities, metropolis, you see in the night time, the cars lights, some people show the lights of the cars as they're moving, photographs. Okay, this cycle graph is like that. Okay, so these graphs, they are helpful in training and evaluating the workers. You can train them, you can tell them what mistakes they are doing and all. Okay, then there are disadvantages for these graphs. And see, now when you are tying light bulbs and wires are hanging around that person, the worker may not feel comfortable. Okay, that is one disadvantage. Then sufficient photographic practice is necessary to achieve good results. So a person who is trying to make this cycle graph and chrono cycle graph good, he should be a good expert in that, with much experience. Then only he'll be able to do it. And the third disadvantage is, that means what, an ordinary person cannot do it. That's what we are saying in point number 2. In the point number 3, the technique has specialized nature. A very specialist is needed for this. Okay, and the fourth one is, the technique is costly. So these are the advantages and disadvantages of the chronocycle graph. Okay, so students, till now we have seen the method study. You see, in the work study there are two parts. One is method study, the other is work measurement. So we have seen the method study till now. Now let us see the other part, that is work measurement. See, the work measurement definition is given here in the first paragraph. It is defined as the application of techniques designed to establish the time for a qualified worker to carry out a specified job at a definite level of performance. That means here, when we are what are we doing? We are making use of some techniques. Why? These techniques are designed to establish the standard time. That a qualified worker means a worker who can do that work. We are not saying very highly skillful worker or untrained worker. We are saying an average worker, a qualified worker. How much time does it take to complete a given job? A specified job means a given job at any definite level of performance. See, there may be different levels of performance. Okay, depending upon that, we can specify how much a highly skilled worker, at what time he should finish, and a little bit lesser level performance person, how much time he will take, and a just qualified person, how much he will take. These times we will be able to establish. You see, so that's why this work measurement is also called as time study. Here we are establishing the time, which is which is called as standard time. We will see all those things later. Now, in the second bullet point, what we can see is F.W. Taylor. F.W. Taylor, who is this F.W. Taylor? He is the father of scientific management. So with him only these management thinkers have started. So you see, this management in industrial engineering, no, they are closely related. See, so these people also have contributed, like F.W. Taylor and this Gilbreth and all those people. Mm. They have contributed because all these managements they were doing in the industries only. Okay, F.W. Taylor, he said something. What? To manage anything, we first must measure. See, that's why, even students, when we teach them, whether they understood or not, you know, to manage their understanding, to manage their training, we have to measure them. That's why we conduct exams. Okay, and we will give them some numbers, okay, which are the marks that they get. Similarly, for everything, to manage, if you want to manage anything, you should be able to put it in numbers. You should be able to measure it. When can you put it in a number? When you measure it. So first we should be able to measure these things. So in other words, a scientific method of fixing standards of production by calculating the standard time. It is see, in other words, this work measurement technique, this is another definition. It is a scientific method of fixing standards of production by calculating the standard time. So here we are going to calculate standard time, okay, and we are going to fix standards for the production. Okay, the work measurement technique is carried out. You see, when do we do work measurement? You see, now two things are there. One is method study and the other is work measurement. So will you first employ method study or work measurement? You see, first thing that you should do is method study. You see, once the method study you have done and you have proposed a method, this is the right method of doing the thing, okay, then only you can take this work measurement. Okay, so method study is that principal technique. You see, first, you see, you can say that both are reducing the time of working, but the drastic reduction will happen in the method that we are selecting. Okay, and work measurement is only concerned with ineffective time, finding out the ineffective time and within that method and reducing and eliminating that. So here first method study is the principal thing. Here this spelling is written wrong. It should be principal, P-A-L-T. Okay, this is the principal technique for reducing the work involved by eliminating unnecessary movements or the paths or operations on the parts. Okay, so method study and work measurement. First you have to undertake this and then only you can undertake this. Okay, then work measurement provides the management. See, in what way this work measurement is going to help you? It will become a tool in the hands of management. Management means what? Higher ups in the organization. Okay, with the means of measuring the time taken in the performance of an operation. If any given work is there, how much time that work should take, you will be able to know. Or a series of operations, if a number of so number of activities or operations you are doing, see how much that should take, in such a way that the ineffective time is shown up and can be separated by effective time. So see, only the effective time we should be able to keep, and ineffective time we should reduce. So thereby what we are going to do, so we are going to remove almost, if possible, completely in the ineffective time, and we'll be able to make use of the operator. You see, the man hours you see, we are paying money. As a management, you are paying money to the worker, so you should ensure that the worker is giving his 100% during the 8-hour shift that he is there. Okay, so you will be able to tell the operators or the workers, you see, this is what you should have done, this much time it takes in 8-hour shifts, so many things you should have produced, but today you produced less. That shows that you are not working properly. So why action should not be taken against you, or why your payment should not be reduced, you will be able to show him with the facts and figures. Okay, then that person will not be able to say. Okay, now let us see about the use of the work measurement data. See, you will be collecting data with the help of this work measurement, and this data where you are going to use. You can use for all these purposes. One is to determine the number of machines one operator can handle. You see, in the method study you have studied about multiple activity charts. Okay, and now you have this data also, that how much time each activity is taking. Okay, thereby what you can do is, you will be able to determine the number of machines one operator can perform. If the worker says, no, I have one machine only, I will operate, you can clearly tell him, no, for handling this machine you require this much time, and this machine this much time, both you can operate. You'll be able to tell the worker. Okay, that's the first point. Second point is to compare the efficiency of alternate methods. Suppose the same work can be done by two different methods. Now you want to see which one you should adopt. For that, apart from the other things like a cost and other things, you should be able to know how much time each method is taking also. There are two methods and you have to choose the best alternative. For that also you have to compare. For comparing, you will use this work measurement data. The third thing is to provide information on which planning and scheduling can be done. Scheduling means what? You will be appointing time fix. You are going to fix time. At this time I'm going to do this, at this time I'm going to do this. You see, when you will be able to do the such kind of scheduling, and when you will be able to do planning, when you definitely have the information that how much time it is going to take. So if you know the time, then you will be able to schedule the things. You will be able to plan the things. So for that also this data will be useful. And the fourth one is to provide information on which estimates for tenders, selling price, delivery dates, and all these things can be based on. You see, suppose if you don't know the time, how much time it takes. You see, suppose we are going to give the tailor for stitching a shirt. You see, he tells you come after 1 day or after 2 days, because he knows how much each shirt takes place, and what is the number of the shirt that is in the queue that you have given. So suppose he has already 9 shirts and yours is the 10th shirt. So he should be able to calculate how much time each shirt takes, and when I can deliver it. So see, that is an example. And similarly in the industries also, you have to quote dates when you are going to give your customer, and what will be the selling price. For selling price also, these timings will be useful. Okay, and for filing tenders and everything, this information will be useful. Okay, then to enable to set standards for labor utilization. See how many workers are required, how many workers will be able to do the things, and what will be the incentive schemes. Incentive schemes means, you see, how much each person should be paid. One may be a very expert, the another person is a raw. You see, one may be able to do may be doing the things at a faster rate. You see, incentives should be based upon the performance of the worker. Okay, so for that also you need work measurement data. Okay, then to help in training new employees. Suppose you have taken new employees. Normally whenever people employ newcomers, what they do is they give them a training. You see, as a graduate engineer trainees, suppose you have completed bachelor's of engineering and you are entering into the companies. So some of the companies, for 6 months they will give you training. Yeah, you will be paid salaries even that period, but they'll be training you for 6 months. That's why that they're more concerned that you should not leave their organization for 2 years or 3 years like that. They will take bond, you see, because for 6 months they are spending money on you, they are training you, and they are paying you salaries also. For the trainers also they are paying salaries, for you they are giving food and all those things. So and if you leave after the training, they will lose. That's why they take bond from the newly coming trainees. Okay, so to help in training the new employees, these timings and other things, these data, work measurement data, will be useful. Okay, then also it is used to measure the measure an employee's work progress, how he is progressing, you know so for that also these measurement data will be useful. Now let us see the work measurement procedure. This is the procedure, similar thing that we have seen for method study also. So see, this is the work measurement, and it's this is done to establish the standard time. Okay, why work measurement is carried out? To establish the standard time. And what are the steps involved? Now here, how many steps are there? 1, 2, 3, 4, 5, 6 steps are there. Say one is select, record, examine, measure, compile, define. You see, these are also similar to those steps that we have seen in method study. A little difference. Okay, that you compare and see afterwards. Okay, see, in work measurement, first step is to select. What should you select? The work to be studied. Here the work is written 2 times. Okay, by mistake. Okay, you have to select the work to be studied. Yeah. Okay, that is the first step. Once that selection is done, you see, normally the people who are doing the work measurement, they won't be selecting it. Their managers and their higher ups, they will be selecting it, and you have to do the work. Okay, but anyway, you can go to the manager level also, so that's why you should know all the steps that are involved. Then second is record. See, you have to record all the relevant data related to the circumstances in which the work is done. Okay, all the information, whatever is necessary, you have to record. Okay, and then next is examine. Now examining means what? You have to examine critically all the recorded data, and also the detailed breaking down of this information, the data that you have collected. Okay, that you have recorded. Okay, so you have to examine it. You should see whether and if something is wrong, you will be able to know that something has gone wrong. You have to record again, or if something is right, you'll be able to know. You see, after some time, you will also become an expert. You'll be able to say the data that is collected is correct or not, and you'll be able to break down everything and say why so much time is required for doing some work. Okay, then next, fourth step is to measure. Now what you have to do? You have to measure this time. So that is what what type of time. Now finally what we arrive at is the standard time. The standard time required for each element of the work. For the work, that can be broken down into small pieces, and for each piece, each element, you will be able to say that this is the time that is required. You have to measure and see, and you have to measure, and you have to arrive at a standard time. See, that is, first you are measuring is only measuring part. Afterwards, you are compiling, or you are computing, you can say you are computing the standard time. So there are certain formulae, and there are certain allowances that we have to give, and all those things we include, and then we arrive at this standard time. Okay, this is you see, work measurement. What was the thing? What was the thing that is done by the work measurement? To establish the standard time. So here we are computing the standard time. And this, after the standard time, last step is to define. You have to define the method that you have measured, and you have to, now this is the standard practice, this is the time that that you should give for this work. You have to tell the workers, and you have to ensure that these things are become a standard practice. So these are the different steps. Okay, how many? 6 steps are there: select, record, examine, measure, compile, and define. Okay, so this is the procedure. Now let us discuss about the work measurement techniques. Okay, see, the aim of all work measurement techniques is to find the time required to do a job by a qualified worker working at a standard space. You see, it is not that just because he can work very fast, he should not be working fast. That is standard pace, not space. Here it is pace. This S should not be there by spelling mistake here. Standard pace. Pace means speed. Okay, and using the standard methods. Okay, this is the aim. Aim means this is our goal, this is our target. What is our target for the work measurement techniques? Is to find the time required by a qualified worker who is working at a standard pace and who is using the standard methods. Okay, so now the various work measurement techniques are given here. See, one is stopwatch time study. A stopwatch, you may be knowing. We will study about this in detail later. Okay, stopwatch time study, then work sampling, then analytical estimating, then predetermined motion time standards, then synthesis from standard data. These are the various work measurement techniques that one can employ. Now here another heading, time studies. The time study, work measurement are the same thing. Okay, but here again it is defined. Time study is defined as the work measurement technique for recording the times and rates of working for the elements of a specified task carried out under specific conditions, and for analyzing data so as to obtain the time necessary for carrying out the job at a defined level of performance. See, most of the people take time study to be the work measurement, but here they are saying it is time study is a work measurement technique. Okay, doesn't matter. In time study technique of work measurement, a stopwatch is used to find out the time required for a. Okay, so that means what? This time stopwatch time study, this only is time study. The other things cannot be called as time study. Okay, so this is the time study. So it should, okay, the time study technique of work measurement, the stopwatch is used to find out the time required. Again, the same thing like a qualified worker and to carry out a specified task at a predefined level of performance. That should have been there. Okay, now time study was originated and developed by F.W. Taylor. And now who is our F.W. Taylor? F.W. Taylor is the father of scientific management. Okay, so he has started this, and he has publicized it, and all the people at that time adopted. Because earlier, before F.W. Taylor came, this management was not using any scientific principles. It was all like a rule of thumb. For this you should do like this, like from the father son was learning, from the son his son was learning, like that. The management was coming. So after F.W. Taylor and his scientific principles only, the management has become scientific management. And now it is not, it is, and at that time, there was a separation between the owner of a company and a manager of a company. Now it doesn't mean that all owners are managing their companies. They will employ specialized managers who may have studied MBA in different specialization, and those people are now managing the thing. The owner need not know anything. Okay, see, rich people are those people who make, who are not intelligent, who may not be intelligent, but they are people who make the intelligent people to work for them. Okay, that's how the rich people are. Okay. Okay, anyway, time study was started and developed by F.W. Taylor, and is concerned with the direct observation of the work while the operator is doing it. See, this is not you are sitting on your desk and you are calculating how much time it should take. You see, you are going on to the shop floor and you are measuring with the stopwatch how much time you are taking. Okay, like that. Now, the need of time study. Why this time study should be undertaken? Okay, there are 7 reasons that are given here. If a new product is launched, then we need to do time study, because no other timings were available before. Okay, it is a new product, so we need time study. Okay, suppose a change in the material is changed. Earlier we have used cast iron, now we are using mild steel. Okay, then the timings will change, because the hardness of the material changes, how much time you work on the machine, on the material, it will change. So if the change in material is there, or the method is changed, then then you have to set up new standards. So for that, again, you need to do time study. And the third reason why we do time study is, a complaint has been received from any worker about the faulty time standards for an operation. You see, a worker may complain and say, hey, you are saying this should be done in 4 minutes. By nobody can do in 4 minutes. Otherwise you measure and see. Okay, we need not just trust the worker. We will conduct the time study and see whether it can be done in 4 minutes or not. See, when a complaint is received, then we can do it and see. Otherwise, these workers will have their own way. You see, every time we are believing the worker, whatever he is saying. Okay. Then, fourth reason is to estimate the time standards before introducing an incentive scheme. Incentive means what? You see, if you do anything, you see, you are supposed to produce 10 pieces in your 8-hour shift, but instead of 10 pieces, you have produced 12. You see, you have, it is not that you compromised on quality. With the same standard of quality, you have produced 2 pieces more. So should you not be paid more? See, that payment extra, what you get is incentive. So for incentive also, according to the standard time, this much it should take. But if a person is more skillful and capable and he is able to produce more, he should be sufficiently reimbursed or rewarded, you can say, rewarded. So that is for incentive scheme also we need to estimate this time standards. Then the fifth reason is, the production of a particular job appears to be exercised. I don't know, I am not able to understand the right meaning of this thing. Maybe they want to tell that a production of a particular job appears to be faulty or not correct, then you may need to do it. If any particular operation appears as a bottleneck that holds up subsequent operations. You see, sometimes one particular operation and one particular work. You see, suppose you are working on a assembly line. You see, there will be a number of workstations in a line, and if one person in the middle somewhere, he is delaying, it becomes a bottleneck. So much work will be just piling at his machine, and the people who are working after him will be waiting for the work, but this person no is not doing his work and pushing it forward. So he becomes a bottleneck there. So if any bottleneck, such bottleneck is there, if any operation or any worker becomes a bottleneck, okay, then you may need to do time study, and if necessary, according to time study, if that worker is not able to cope up, then we may have to change the worker, or we may have to change the machine, or we have to change the method or something like that, so that you can eliminate the bottleneck. Then the last reason why we need to undertake this time study is if any new method is proposed. In the first thing, new product is introduced, and the last thing, okay, in the first thing what we said is a new product is introduced. Here a new method is introduced over the existing one by after the method study. So therefore you need to do time study. So these are the different reasons why we do time study. So for today, that's all, students. We'll stop here. We'll see in the next lecture. Thank you.